In this R tutorial video, we're going to learn about indexing and using logical statements to pull out certain data from a vector based on some criteria that we set. To do that, we're going to need to learn a new function called the concatenate function. So if I have a set of data that I want to store in, say, the object called myVariable, I can assign the word myVariable to a vector by using the concatenate function, which is just the letter C. So say I have some data that is the following numbers, and I want to store these into the object called myVariable. Well, if I submit this line, again, a couple things are going to happen. It's going to submit it down here on the console, but now I'm going to see this new item in my workspace or my environment that is actually a vector of numbers. So now that we have a vector of numbers, we can actually do a lot of fun things with it. So say I wanted to take my variable and I wanted to take every single value and multiply it by 3. I can just take the object name times 3, and now I get those 5 numbers displayed, all multiplied by 3. I can also include my variable in a function. So let's use our square root function again, ask for the square root of my variable. And again, this function is going to be applied to every single item in that vector. Now notice one thing here. Contained in my variable vector is a negative number, and you can't take the square root of a negative. So what it got me was the square root of the other numbers, right, that it was able to perform. And then this NaN came up for the -9, and that stands for not a number. Something that we can also do with this object called myVariable is we can assign a modification of it to some other object. So just like we did here when we assigned x squared to y, we can assign maybe a new vector, myVariable2, to be myVariable times 3. If we wanted to see what was in myVariable2, we could either look over here in our environment, or we could just ask R to display it for us. Some other really useful functions that we would want to use on vectors like this are the mean. So if I want to take the mean of my variable, I'm going to get a single value, which is literally the mean of all 5 of those values, 22.8. Another helpful function is if I want to know how many cases are contained in a vector. Here my variable is pretty small. I can see that there are 5, but if I had a vector that was very long, I might want to ask for the length of my variable, and that'll just give me the number of cases that it contains. And finally, we've got the sum function, which is just going to add up every number in that object, and I get 114. So we use parentheses when we want to use a function and have some arguments. We're going to use the square brackets to index a vector. So if I want to pull out the second value in the vector myVariable, I'm going to use square brackets and ask for 2. Right, and I see that 28 is the second number in the object myVariable. So beyond just asking for a specific index, we can actually ask for the cases from my variable that meet some specific criteria. If I give R a logical statement such as my variable is greater than 0, now I know that I have 4 positive numbers and 1 negative number in the object my variable. If I give it this logical statement, right, my variable greater than 0, I'm going to see a true-false output here. It's basically looking at this criteria and then going into the vector myVariable and saying, is this statement true for each number? If we include this logical statement in an indexing, so if I ask for my variable where my variable is greater than 0, instead of just pulling out, say, the second number of that vector, it's going to pull out wherever this is true and give me those numbers in return. So what this is going to give me are the 4 positive numbers from my vector. The other types of logical statements I can use are the symbols less than, greater than, equal to, which is two equal signs back to back, not equal to, which is an exclamation point and an equal sign. So just to see what I'm talking about here, if I want to take the cases of my variable where my variable is equal to 12, I'm going to include this double equal sign. That's telling R it's a logical statement. Run this, and I'm going to get the single case where my vector equals 12. If I ask for the same thing, but instead of equal to, I say not equal to, I'm going to get the other four numbers from my vector.